All right. So one of the interesting things was that there's right now I think there's a wide variety of typed languages from kind of I'm thinking Alex here as the kind of prototype of the super statically typed languages, and Dave as the kind of representative of the kind of very dynamic languages, and now we have everything in between. So I would like to ask Alex and Dave, what do you think of all this kind of this optionally typed and gradually typed? Isn't that kind of going the wrong way? It's taking away your bread.
Thank you for starting me off, Eric. It occurs to me there are as many people in the audience as there are up here. So maybe, yeah. Bjarne was talking yesterday about more expressive type systems. I think we have all the expression in the Java's static type system that we need for now. We were talking earlier about gradual typing, and I think where languages want to interoperate, that's obviously a nice feature to have at the boundary. And on the JVM, we're very concerned about having multiple languages running. There has been less interoperation of those languages than you might have expected, actually. They do tend to be a little in their own worlds. But we've certainly thought about, and we've seen what C#4 did in that regard. And so we've certainly thought about static where, what's the line? Static where necessary, dynamic where useful. I think that's something we are keeping an eye on.
All right. That, by the way, was a quote from Bill Gates that I stole.
So I shall give two answers, one in my regular voice and one in a high squeaky voice. But seriously, the object all sublime I shall achieve in time to let the punishment fit the crime, the punishment fit the crime. I'm not in good voice right now, but the point is there are a lot of different tasks and a lot of different contexts, and different sorts of types or presents are appropriate to the different tasks, which everyone here probably knows. But that said, I have been pummeled by some type systems in my life to no good use where they didn't seem to buy me enough for the work, and that's the real tragedy. The biggest complaint I have against types is that they're objective. So if something is of a type, it's telling me that without running my program, or without maybe just running a slow compiler or a fast one, I know that that thing upholds a bunch of invariants. But in any given particular use of it, and the small talk and dynamic guys know what I mean, I only need a few of those invariants. And which ones I need may not be determined at the point of use, but the caller of the caller of the caller of the caller of the point of use, or the heap, or the whole program. And yet, the type systems I have experience with, which aren't a whole very many and not terribly current, don't do that. They force me to way over-specify, and the functional ones seem to force me to look inside of objects and know way too much about them. Again, coming from a dynamic, small-talky, I throw a message, it works, whatever, maybe it doesn't point of view. So the serious thing I'd say about types is this business of objectivity and subjectivity, and the danger of designing from examples. But that's another rant, so I'd better give the mic to someone else.
All right, thanks. So I have a question for Gilad, because I think now TypeScript is also kind of doing unsafe covariance, and I'm very happy about that. One of the things that when the CLR introduced generics, I wanted to have unsafe variants, but now it's kind of getting accepted, so I really like that. So can you tell us kind of why you kind of did that and whether that was a good choice? Would you do it again, or would you introduce kind of also covariance?
Okay, so first thing, I didn't do that because it was already decided when I reached the Dart project to do that. Now, what I would have done is not put in generics at all. But given that you are putting them in, yes, that's what I would do. And again, this wasn't our idea. We stole that from Beta, which had covariance essentially everywhere and dynamic checks to enforce essentially contravariance when it was necessary. And like I said, I would not do that again because I wouldn't put in generics. Now, the main problem with generics is I've done them many ways and I've never found a good way to do them, and I haven't seen a good way to do them. The problem is that it's not obvious that there's an alternative because they do buy you something. And since I don't have a constructive alternative yet, it's a little bit harder to knock them than I would like.
So, if I may ask you a question, Gillen. I've always been a fan of the virtual type way that the Beta language went because I thought it matched well with the object-oriented programming style where you make things more specialized by making subclasses or refinements, whereas the parameterization in generics matches more the functional style where you add variation with parameterization. So when you say you haven't found a way you like, the implication is there's something about Beta I haven't thought about that's a drawback. So do you want to say about that?
First of all, in sort of broad terms, I agree. I think that generics, as traditionally conceived, are a functional transplant that is a mismatch in the object-oriented world, which is not to defend Hindley-Milner in any shape or form. But it's also true that, yeah, there are drawbacks to Beta. But I do think my instinct is that the answer is something like you just pass class objects or type objects as first-class entities as regular parameters. You don't introduce a second parameterization mechanism that is purely static. The trick is, what do you do about the static analysis? How do you warn people? How do you understand that stuff? And I don't see a good solution. One thing about the Beta solution was that it forced you to explicitly declare subpatterns for each parameterization. But there's a very nice solution to that that maybe Mats wants to talk about. Unifying genericity, you might remember someone had a thesis about that. Mats actually has a PhD, and he wrote a very nice thesis that worked on this problem.
Okay, so the Mats kind of pitch your PhD in 10 seconds.
We won't hold it against
Wow.
No pressure.
I did not expect this. We're discussing Beta and my PhD thesis at this event. I think that I like the idea, the unifying idea of that being just one form of refinement in a language. In function languages, refinement is by application, and in traditional object-oriented languages, it is by extension, essentially. And there's something nice about that. Now, I do actually find that I have to admit, having worked on TypeScript, there's something incredibly liberating about just not having those types around at all at runtime. There's something really nice about it. It's not good for determining, it is really not good for determining whether you're doing things correctly. Like, if you want to do that, you probably need to keep your types around. But if you just want a nice tooling experience, if what you're doing is just exploring and figuring out what should I type next, and having your tool do it for you, type systems for that just are lightweight on top of runtime semantics. I think there's something really, really nice about that. That's certainly I'm not saying that's good for everything, but that's certainly a space that I've come to appreciate much more.
So,
Did I dodge the question well?
That's very evasive, yes.
Thank you.
And I have a question for Jan.
Oh.
I was really surprised, and this is probably kind of okay, right? I was really surprised that you said that you're going to make R more lazy, because in Haskell everybody's trying to make it more strict. What's going on?
Well, so the question is, why make R more lazy? And the reason is that it's already vectorized, and the granule of computation are fairly coarse already. And if we could just batch some of that coarseness into bigger operations, we can send it to GPU. So all of the difficulties functional languages have is because they operate element by element. In R, by definition, you're already vectorized. So it's much, sort of thinking about sending it to a GPU is natural. And I think, but we need bigger operations. If you're just adding two arrays, the GPU won't help you. So that's the thought.
So really, the SQL guys were right.
Of course.
Okay, I knew that. So then, Andre, I have a question for you to kind of continue with the kind of covariance thing, because you mentioned that D has generics, but you carefully didn't mention variance.
Covariance or contravariance? D has covariant return types because it's sort of the obvious thing to implement. And we're considering also introducing contravariant parameter types, which is also kind of a natural thing to do. And it was kind of pending interesting uses, and we couldn't find any interesting uses, so we kind of punted on that. They make sense, but just because they make sense, we didn't want to implement everything that makes sense. We didn't find a compelling use case. I know C# introduced them recently, is that correct?
C# 4, yeah.
Years ago? Okay, so C# has them, Java doesn't have them, right? Doesn't have either.
Variance?
So Java introduced them recently.
No,
Oh, okay, I'm wrong
yeah.
2 counts, okay. So probably we'll end up kind of going with the crowd. I didn't want to point you something, because you mentioned like covariant and covariant is covariant.
Yes.
And contravariant and contravariant twice is
Yes.
that's like plus and minus in algebra.
Yes. And that's why in Scala they're called plus and minus.
I just, I guess I've never understood what you guys thinking when you're doing this covariant function arguments. Are you insane? You're just completely crazy and wrong. So I don't understand. If somebody could explain to me why this is a good idea, it's like,
Because Eiffel did it.
No, I can explain it.
okay.
Okay.
So I'll explain it, then I'll ask my real question. This is from Ola Lerman-Madsen's Uppsala talk. That is why I fell in love with beta. It fits the way people think, and here's the motivating example. I have a class that's a store. It sells merchandise. I have a class that's a shoe store. It's a subclass. It sells shoes. Shoes are a kind of merchandise. There's a simple covariant example. But my real question to you, Eric, and to everyone else here is, there's something really fishy about this whole deal, because if you've got two things, covariance and contravariance, you probably have many of them. The fact that all you can imagine is two sounds to me like something is wrong with the whole basic framework. Where are the rest? Where are the rest of them? Okay, so if you have three, there should be 4, 5, 6, 7, 8, and 9, right? So to me, at the level of a nice seeming theory, there's something woefully lacking in symmetry, for want of a better word. And there's a question.
Because we have true and false, we need to have.
Oh yeah, I agree.
4, 5, and 6.
I agree. I have an infinite. I don't use Aristotelian reasoning. I find it very non-productive. So I use more of a Bayesian infinite valued logic. Absolutely.
Are you sure you get the concept of duality?
But there was somebody behind you that could explain covariance. You were nodding. You said that was a good idea. Come on,
Okay,
yes,
okay.
yes.
I'll take a swing at it.
Yep, good.
Okay, so one of the reasons, I kind of threw this up on our example earlier in the talk, but when you have relationships between different arguments, sometimes you're staring at it, and as the programmer, by inspection, you know it's correct. But trying to describe that to the type system now may require a PhD. So I think that there are places, especially in really dynamic languages, there are use cases that just kind of arise from natural usage that to a type system would be nearly baffling to the common programmer.
Modeling.
So I think Gila had said that generics is something that was imported from functional programming and kind of dumped into object-oriented programming. I like that argument and that's why it doesn't fit well with inheritance or subtyping, because functional languages don't have that. But now there's a thing, I think, another danger, where we are importing lambdas from functional programming. And so aren't we kind of setting our developers up for yet another disaster with lambdas?
Fundamentally, I don't think so. But my view is that every new powerful feature, new to our community, is going to be misused and overused in a massive way. I think there are enough good examples of use of lambdas to make it worthwhile and a good thing. But certainly in C++ and the C++ community, over the next 5 to 10 years, we are going to see massive overuse. That happens with virtual functions. It happens with templates. It happens with just about anything that really works. And by the way, I was sort of surprised by the statement that generics came from the functional programming community. I certainly didn't notice that when I put them into C++.
Dave, you also had something?
Well, I just wanted to say that if I were doing a single paradigm language as opposed to a multi-paradigm language, and if I were doing a single paradigm object-oriented language, I would figure out a way to get rid of lambdas and control structures because they just don't feel object-oriented to me. Even arguments to functions in a single dispatch object-oriented language, it just doesn't feel right, but I'm not smart enough to pull it off. But maybe someone will hear these words and do it and be smart enough. It's a holdover from Fortran, for goodness sake. You know, the Smalltalk true and false show that in a way you don't need so much at the bottom, but then you've got if, okay, it's implemented in blocks, but you know, we have objects, we have refinement, we have dynamic dispatch. We shouldn't need anything else. I just can't quite pull it off. I'm stuck in old habits of thought.
So Dustin, why is there no Smalltalk for Visual Studio then?
There was a Smalltalk being worked on for Visual Studio, was there not? There was an Iron Smalltalk at one point.
Yeah.
Yeah. So.
Where did that go?
I think it's. What's that?
David Simmons stuff, S#.
Oh,
Yeah,
he
yeah.
works now on Visual Basic. Or it worked.
Worked. Yeah.
There was no market, sorry.
Yeah. Only David asked for it. So.
No. So this is kind of something. I mean, and probably this has been kind of answered many times before. But like a lot of people kind of say, "Oh, Smalltalk was so great," but then why didn't it kind of why isn't everybody kind of selling Smalltalk like crazy?
Images. Images. That's the only. That's it. It's a terrible idea.
Had a bad image?
No, there's the idea of the image that you load up your Smalltalk into this environment, and then you work in it, and then you save it down to the machine, and all your work is stuck in that image. It's like, how do you get your code out? How do you give it to somebody else? How do you deploy? How do you ship the software? It's non-trivial.
So how do we do kind of sharing code with basically core dumps? That's your question.
Yeah, basically.
So the self-transporter was a solution to the problem of how we take a web of objects in a dynamic language embedded in an image and save it out to source. And we can read it in. The big lesson was you need more information than you do just to run the program to save a piece and bring it in. I think the reason Smalltalk and Self didn't catch on has to do a lot with the fallacy of the typical mind. How many of you know the blind spot fallacy in here? So, you can look at a particular optical illusion and the dot's right over where your optic nerve exits the retina, so you can't see it, but instead of seeing a gray haze, your brain fills in white, and you're sure that there's just white paper there. And the human nervous system has built-in distortions, and that's one. The things you can't see, it extrapolates effortlessly so you think you can see them. One of the things we can't see are what goes on in other people's minds. And what our nervous system does for us is it paints the picture that what's in your mind is the same thing that's in my mind, or yours, or yours. And it does this at a very deep, unconscious level. So we are all pulled by the illusion that other people think the way we do. And I believe that there are some people for whom small talk and self are absolutely fantastic languages. I think I'm one of them. But I suspect it's a minority of the professional programmer population. And that's my guess. And likewise, some of the things that people really love and use just don't mesh well with my brain. So we're different.
All right. So, Mats, I'll come back to you. But first, I'm going to kind of give the guests a chance. David.
I would like to make a little statement about living in a world of images. Just because you have that as a development convenience doesn't mean you shouldn't know how to put the system together from first principles. And sort of on that note, if you say images are bad, you might have to say databases are bad, or virtual machines, that you could build up and, in effect, snapshot or shut down, or maybe a computer operating system that you could shut down. It's the same thing. If you don't know how to build your artifacts from first principles, they can get lost.
Thank you. I was expecting that you also would make a Mathematica remark, but that will come later.
No, we don't have a snapshot.
All right.
Well, I think images are great. I've had some of my best labs because of images. So working in Self, I know there were a few Danes that worked on Self when it was being developed, and it was essentially being distributed through an image that was copied and sent out. And so I know for a fact that in the image that I used to teach my students were the Danish words for fish and horse on several occasions. So it's really great because you can see all the traces of what actually happened during development, rather than some fancy post-rationalization of what the world's supposed to look like. It's really entertaining.
All right. So I have a question from the audience. By the way, I think TeX also kind of does a core dump at some point, and then when it loads, it's kind of
LaTeX?
Yeah. So, all right. Question from the audience.
Hi. So actually, this question fits well with the last comment from David of my nervous system is just going to assume what all the other people's are thinking. But so from the R talk, what was interesting is people from the R designers analyzed R programs, and the result of this analysis, I assume, influences the evolution of R. Given we have some new languages also, who else is doing that here?
So are you saying who else is using data from the usage to kind of design their programming language instead of just having the kind of guru decide?
And I assume this is what programmers want and like, and so this is what I'm going to put in my language. Now let us rather look at programs and see what programmers are doing.
I assume that Hack.
All right. So here, Microsoft does this, I'm sure.
Well, one interesting from the ECMAScript standards perspective, one nice quality of JavaScript is that you have access to an awful lot of it on the web, and so you can crawl the web, find all the JavaScript, and then do queries over that. And so whenever we are looking at breaking changes, which is normally very rare but very, very corner case things, but we're able to actually go out and look at the Alexa top 10,000 and say how many times is this used, and if it's used more than once, probably it's not going to happen. As a breaking change. But we have actually done all that analysis to make sure that if we ever do try to make breaking changes, it's going to affect effectively no one. So that's one example.
I'm going to get a single question.
Okay, go ahead.
Very briefly, the interesting question that's raised, what are those data good for and what are those data bad for?
This is a question for me?
Anybody, triggered by your question.
Matt?
Well, we've done a little bit of data-driven design on C# as well. What it's good for is very incremental changes. We've had a few features where we've figured that something would be convenient, and we've done some data analysis on large bodies of code to essentially, using Roslyn and all that, to essentially see, would it be convenient enough? How many cases are there where the code would become nicer? And concluded there weren't enough. People wouldn't have, saved enough effort. So that's kind of nice and incremental, but for creating a new language or even sort of qualitatively new features in a language, I think it's very hard to use data to do that. But you need some other mechanism to get there and to validate that it's a good idea.
Jan, before passing it to you, I have one question for Matt. Like, you now talk about languages, but what about APIs? Because we built like the language is only a small part of the whole ecosystem, and my guess is that like 90% of the APIs or 90% of the methods are never called.
Yeah, that's probably true. There's a conundrum there that if you could sit down with your or with your users every day and say, let's add a new method today because a lot of you ask for it, that would be good. I think maybe that goes more to the sort of traditional length of the cycles with which we release software. We release a bunch of stuff every 3 years traditionally, and because we want to cover all our bases, because it's a long time before we can respond to the next request, and then most of it sits unused. I think the more we get to more rapid release cycles, the less of a problem that will be. The more we'll kind of have the finger on the pulse of what's still missing in a given API, or what are the spaces that aren't covered well.
Jan?
So to answer Dave's question, what is the data good for? The data is good for at getting a snapshot of programming idioms at one point in time. So for instance, in 2010, we looked at JavaScript, and we found out that the way people were using JavaScript in the wild was very different from the assumptions made by virtual machines at the time. And that study sort of fed back into the design. But what it doesn't tell you is what will be the reaction of programmers to the changes you make, right? It is because programmers take the language you have written with all of its deficiencies and warts and design for it. You improve the language, they will change the way they work. So, it's a continuous process.
Can I say one thing about
Sure, and then to your left.
Back on images, I had a PhD student, Ola Eason, whose dissertation was about how to take a self-image dynamic web of objects and just write out those slots of those objects that were necessary for a particular application. Got a very good result, type inference, completely dynamic language.
I'll just say that looking at code is absolutely necessary, because people write code you wouldn't dream that anybody would be writing. And I would say that the single most useful effect of looking at a lot of code is to figure out what needs to be removed. And you have to find alternatives for it.
I'll be right there.
There's plenty of questions, so I'll be quick. I can think of 2 cases in which we've actually used data. I really like that question. One is the valid range propagation that we use to restrict things like you assign an integer to a short integer and you assign a long to an integer and you lose data and stuff like that. Valid range propagation we use for things like restricting these in a way that you never lose information, but the downside is you need to insert casts once in a while. It's a very simple flow-insensitive, context-insensitive analysis, and we thought, are we going to put the effort to do the flow sensitivity and everything, or not? And we just applied the simple version against our own standard library, which was a large body of code, and we figured that in all but 2 cases, we didn't need to insert any casts, so we thought it's good. And it was indeed a success, and we saved a lot of effort on implementing the more precise version, which is kind of unwieldy to do it. The second thing is we want currently to eliminate comparisons for inequality between signed and unsigned integers, which is a classic source of errors in C and C++ programs, and essentially it's unsound. It's just not a good thing to do because they get converted to unsigned and depending on relative widths and all that stuff. So we want to do that, and we have a mechanism. We have a few smarts about it. And, it triggered like 200 breakages in the standard library, and we kind of need to look into it because it didn't find any bug but it did have a lot of false positives, so we're not going to do it. In contrast with the variant range propagation, we did find bugs, and it did have very few false positives. So that would be one case of using data.
Thank you.
Thanks. So my question is about hygienic procedural macros. And I think if they're lightly used, they're great. Like any powerful feature, they can be wildly abused and make programs hard to read. Anders once posited to me that he doesn't like them in C# because he can't then change the language over time because he would be breaking the public's code. So I'm curious if other people have strong opinions on supporting them or not having them in the language because they're too much. Oh, and we know you can do it in an infix language because we saw Dylan do it.
All right, macros. That subject has not been discussed yet.
Macros. So, okay, so my name is Dave, and I'm a macroholic. When I programmed in C++ in the early days, we used macros for all kinds of things. We even used second-order macros that called macros, so we could factor our code. Today, new features we wouldn't have to. I really, really, really dislike macros, and they make me learn two different languages. They make me understand two different execution times. They give me error messages I can't possibly understand. And, when code breaks that's running that was the result of macros, the result is really hard to deal with. So some of the languages I love, like APL and Smalltalk and Self, do very nicely without macros, thank you. And I think that the newer things in C++, and you have to remember my extensive C++ experience is from the late 80s, okay? I think we probably wouldn't need them anymore. Bad, 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 bad.
Yeah, I would say you understate the problem. Macros are evil, and in C++ they have only one good use, in my opinion, which is to have conditional compilation, conditional inclusion, I mean, and that's a feature we would rather not have if we find an alternative. And the thing that makes them even worse, I'm talking about C++ macros, not hygienic in any way, they also spoil your tool chains. They are the deep reason why you don't have good enough browsers, good enough refactoring tools, good enough just about anything. They're just poison.
Just to add like a couple of words to that. So I helped work on the module system in C++ that I think may be getting proposed. I don't even know what the...
There's a lot of work on this
Right.
going on. I do not know which one will win or whether there really is more than one.
Right.
There's more people working on it.
So, and one of the reasons why it was so tricky was because of the pound define. You put that in your header file, and now you include that file. Anything after that can be completely changed. It doesn't matter what the symbol name is. There's nothing off limits.
Well, I think C macros give a bad name to macros in general because they're poorly implemented. So that would be one thing to consider when assessing macros. Second, macros have, the problem with macros is that they have little mathematical underpinning. If you think of things in programming language, they always have they come from somewhere. Keywords come from natural language, very nice. Expression, functions, everything we have from math. So there's a nice structure to it. There's a nice origination of everything in programming. Macros do not have such. And actually it's unnatural in natural language. Sorry for the unintended pun. It's unnatural to define macros to change syntax. No spoken language ever does that. They do have things like synthesize words and things, but they never define syntax. So that would be. That said, languages such as Lisp, which have a relatively high overhead for invoking functions and such. They use macros as a crutch for faster execution and things like that. And that's a use. I would say that things like compile time evaluation that we have in these is better.
All right.
Yeah, and from the tooling perspective, springboarding off of what Bjarne said, it is really, really hard to do tooling, any kind of tooling. Even getting completionless right, even with just conditional compilation, is really difficult. If I define something as a structure in one, in debug mode, and a class in another one, I don't know what to do with that, right? And I thought long and hard about C++ and how to do better C++ and how to do better refactoring around in the face of macros, and it is a hard problem. So, yeah, no helpful there. Not helpful.
No macro lovers here, so. But maybe in the audience, or maybe a different question.
So my question is mostly for Bjarne and Andre. I consider myself a pretty good C++ programmer, and I've done very evil things with templates. I confess, but they're very, very useful, and the code kind of disappears, and you get this really raw, assembly that's very, very quick, and that's probably my most favorite part about C++. And all the patterns that you can get, type erasure and curious recurring template pattern, and all sorts of crazy things. Enable if, that does very cool conditional compilation, and I can write that function in one function using templates that you wrote up there with the allocator. But anyway, so I'm looking at D, and there's a lot of things that are improved, the module system and all these kind of things that I think C++ is going to have a hard time, we just talked about macros, with its legacy debt getting rid of. And I love D because it's learned from all of this, and as you said, there's some really great patterns in there. The only thing that I have issue with, and I want your current, most up-to-date formal stance, is on garbage collection. And that I would love to convert my C++ code, but it seems that the standard library in D has this bias toward garbage collection, and even though you can not use it, it seems that it's very hard. And things like the static if and whatnot, it's just, I can imagine the performance and stuff that I could get out of it that I would have to write 80 times as much characters in C++ to do, and I'd just rather do that in D, but I can't buy a garbage collection, and that just turns me completely off. So I'd like to hear both of your stances on my long sentence.
All right. Garbage collection. Evil or, heaven?
It's sort of an incomplete solution and not my ideal. If you've written a lot of messy code in C++, you can plug in a garbage collector to tie you over till you can fix the problems. So it is just not my ideal. If you heard my talk yesterday, you heard the arguments. Basically, it handles only memory, and it's a centralized resource. I don't like that. About the issue of templates and such, when I put templates into C++, the year was sort of 1988. And I wanted 3 things, as I said, and I got 2 out of 3, and I thought I necessarily had to pick those 2 if I couldn't get 3. And today, thanks to a massive success out in the real world, we have a lot of really strange template code, and the error messages and the code complexity is just amazing, and it demonstrates to some extent the utility of the thing. People are willing to suffer that much. Something was right. And so one of the efforts that I've had over the years has been trying to simplify this and allow the parts of template use that I think are most important and I like most to be written much simpler. A basic example of that is the constant expression functions that was designed by Gabby Does Reyes and me, and I remember explaining it to Walter Bright, for instance, and you can move faster in a new language, so they got it sooner. But the design was for C++. Similarly, a lot of template metaprogramming that generates values is, I think, wrong. Templates are really good to generate types and operations, but for numbers, it's a hack, and constant expression evaluation takes care of that. A lot of the stuff that has a nice type basis can be dealt with concepts, which I hope that we will get as a technical specification in 3 weeks. You can download the implementation now. And that leaves some of the things like expression templates, which are basically a manipulation of abstract syntax trees, and there's not much type stuff you can do there, and it's inherently ugly. But yes, if you get something sort of right, it gets overused, and you have to compensate for it, and we're on that track.
Thank you. Garbage collection.
I'll be quick. It's recognized that there's going to be always a category of people who are simply. It's like it's like being pregnant. You have garbage collection or you don't kind of have it, right? And
in what way is it like being pregnant?
in the sense that it's
bloated.
it makes you bloated, right?
You aren't.
When did you become an expert?
I meant it's a strict Boolean value. So essentially, there's going to be a category of people who are essentially like going to full stop at any sign of any garbage collection being around within a radius of a mile. So we recognize that clearly, and we're working on weeding the standard library off of it. So essentially, we have right now we have a no GC attribute, and essentially can qualify entire parts of a program, an entire program as being a no GC program, and that's going to be statically checked by the compiler. So that's one path of that's one access. The other is essentially weeding the standard library of unnecessary garbage creation. That said, I'm amazed about how many people don't know that, for example, reference counting is, as traditionally implemented, is slower than garbage collection. Even when the garbage collection does happen, reference count is kind of just right now with very recent research is kind of inching toward the speed of garbage collection in systems that have enough memory. Then, of course, there's constraints that don't have enough memory, so they don't have 3x the magic number, 3x the working set of the program, so for those GC is kind of a bad option. So clearly, we're working on it. So we want to create less garbage. That said, so there is a proposal for adding optional GC to C++ as well. And I think the premise here, and Bjarne, let me know if you have anything to add. I think the premise is that these languages, such as C++ and D, they create a lot less garbage in the first place. It's litter. And actually, Bjarne has coined this like litter collection. That's what's going on in these languages. So the patterns of garbage creation are very different from those in languages that actually rely on garbage collected runtime for everything. There's going to be, we have programs that are in D high performance garbage collected and they never collect because you create like 180 bytes of garbage in command line processing. And then you don't do anything else, right? With allocation. So I would say it's partly sort of a psychological barrier. So as soon as you have a garbage collector, I'm not going to talk to you anymore. Partly it's what?
Nothing. I think there's plenty of application for garbage collection. I will use garbage.
Right. It's not. It's just you're not in that business, right? And I'm not either. So.
Libraries need to be that way because they're more or less have time constraints in real-time systems.
Totally. So what we're working on right now is to not impose it on people. So to say, if you want to bash a quick script together that's going to be 100 times faster than Python and the same length and it's just going to work, you're just going to use the GC and it's just going to be there. If you want a high-performance application and stuff, we're going to have to support that too and essentially not push it the GC against you. So essentially, we're working on it. I think GC has its place. I don't think we should push it on people in a systems language, and that's the way I think.
All right. Yes, of course. And then we have the last question.
I'll try to be brief. In 1984, when I published my first garbage collector, we didn't have any type systems that would prevent dangling pointer problems. And when I wrote virtual machines later on, I didn't have a type system that would prevent dangling pointer problems. And it's, boy, the cost of those can be so high that if it's a choice, garbage collection can be efficient enough for so many things, and then you never have to debug a problem where the symptom of the problem has nothing to do with the cause. No observable relation. Wow. So if I ever had to live without it in programming, I would hope to have some other solution so that I couldn't have a dangling reference. And I think they might be out there. I'm not up on them.
Thank you. This is not the last question. Charles, give you special permission.
All right. So I kind of actually have two questions. So please phrase your answer in the form of a tuple.
One finger, raise your whole hand.
So the first one's kind of a softball, and it's you are stuck on a desert island, and your only hope of escape is to write a program, but it can't be in a language that you've either spent most of your career working in or one that you've personally developed. What language is that? And then my more serious question is, so metaprogramming is actually kind of an interesting challenge. I think that the lengths that people go to, as has been observed by some of you, to be able to take patterns about patterns, right? Like when we write a program, it's a pattern to solve a problem. But we often realize that there's a higher order pattern that we also want to be able to codify somehow. But very few languages offer really good mechanisms to do that. Like how do you see that problem getting tackled? Because for a lot of people, the solution is take some other completely different language and generate code in the language of your target choice. But that seems kind of hacky. So what else is really likely or possible?
Or use macros.
So, how do you see the many cores fantastically impacting your programming language, either positively or negatively?
Okay, so we have the desert island question, the higher order patterns, and then the many core question. Who wants to be on a desert island? I think you.
Well, yes, I guess I will be on the desert island. So the desert island question is, what are my options? Nothing that I know very well and nothing that I work on. Are these the constraints?
It can't be a language that you personally developed or have spent most of your career working. It's gotta be something.
No OCaml.
Okay, so OCaml is off the table. I guess it's a tough choice. I was going to say Haskell, but he's going to be too happy about it. So I'm not going to say Haskell on purpose, just to piss him off. Yeah, I guess depends what the task is, but C, C++, maybe Java, not Haskell. That's my answer to it.
I'm going to take the microphone away from him. Desert island.
Desert island question. Well, I think I was going to say Haskell too, but then I thought, I can't implement GUIs very easily, and there's just it's all this research that I have to do. So I figure I'd pick Smalltalk.
Even though there's an image.
Yep.
Even though there's an image.
If I was the only person on the desert island, it wouldn't matter.
Okay. And now I'm going to ask Gilad, because he cannot say Smalltalk.
So I was debating whether to say self, because I haven't really done much work in self, but I suspect that'll be perceived rightly as cheating. So now I have to scrape the barrel for something else, and so, scheme.
Oh, that's a good one. There we go. That's a good one.
Good. All right. So, Luke.
Are we still on desert islands?
Yes. No JavaScript.
No JavaScript, no.
No F-sharp.
No F-sharp, no C-sharp, no, yeah, that's a lot of things. I would actually say PHP, maybe with Hack.
Yes! I would do that too. All right. Then the other question was about higher order patterns.
Well, I had an answer for the desert island.
Oh, you had also desert island. Great.
I was struggling to find an answer. I think it'd be assembler.
That's what I would say.
And I hope it's not cheating, although I got my start writing cross assemblers in Fortran on a mini computer. And the reason is, if I were on a desert island, electrical power would be at a premium. And I think I could and also debugging time. I'd have all the time in the world. So I think assembler would be it.
Yeah, you could toggle it in with the switches. That would be fun as well.
Okay, for my senior project, I took a SCAMP evaluation board in the late 70s and built a Pong game out of it. You know, built backplane, built joystick interface, wire wrapped it all, did it all incrementally. Oh, I need gates here, drew them on the diagram, put them on the board, did the wire wrapping. Programmed the thing in machine language by cutting a paper tape in BNPF. So each byte started with a B, 1 was a P, a 0 was an N, I think, and each byte ended with an F. Typed it into a teletype, punched the tape, and burned the EEPROM. So I've been there.
That explains a lot.
Boy, you were lucky. We had to chisel the bits into the stones ourselves.
All right. So, well, can you say something about design patterns or the higher order patterns that seem to be kind of appear out of the fog?
Yes, I'm channeling what you're saying with ENSO. It's designed to capture these higher level, higher order patterns and be able to express them directly. But I did want to mention one other thing that I think is not necessarily successful in the long run, although it's successful in the short run, which is designing DSLs around chunks of syntax that are already lying around, like your type system. So people take types and use those as input to generators and then generate code, but those types are fairly weak in terms of their expressiveness. They don't have constraints in them. So people are getting a certain amount of mileage out of kind of running meta programs over their own syntax, but at some level that syntax becomes limiting because it's not really general. And so I think that it's going to be interesting to see how that plays out. That's why with ENSO I've gone with just arbitrary DSLs, and you can write whatever you want and express whatever meta pattern you need. But there are some costs to that too. But I'm definitely going over to the dark side of that kind of divide.
And Jan, so there must be a reason that you're kind of looking at R that has to do with many-core, or not?
Yeah, R is a single-threaded language, so I guess it goes in the or not category. But this is obviously something you want to parallelize. But yeah, it is hopelessly single-threaded as it is implemented today.
And so one interesting thing is that like R has copy on write arrays, but another language that has that is PHP. So can you say a little bit about that? Is that a good thing? Is that a bad thing? Do you want to get rid of it?
Yeah, so actually, surprisingly, it has been a very good thing because it allowed us to share a lot of data across multiple requests. So one thing that is very important to us is to be able to have one machine. So there are different kinds of parallelism, right? And our parallelism right now is a bit embarrassingly parallel because we have so many requests to get in, and all what we need to do is redirect that request to the right to a machine that computes that request and comes back with a result. And so if a machine has many cores, it's the distribution model stays the same, but what we gain is that we can share data on that same machine. So now the value semantics that R has and that PHP arrays have as well is very interesting because now we can have one value that is shared across multiple threads that are really single-threaded and are not supposed to share any data for free. And users don't have to know about it and they don't have to think about it. But PHP arrays have other problems, right? They're a bit the jack of all trade for data structures, and we would like to split them in different use cases, but not necessarily the value semantics part. The value semantics has been very helpful to us.
All right. Any more questions from the audience? Yes, there was one question. Sorry to let you wait for so long.
This one kind of relates to the whole many-core GPU, or, the hardware side, but it also goes to this dichotomy of, there's a part of me that really passionately loves the extreme, dynamic object-oriented David view, but then there's another side where, because of the constraints of the application domain that I'm interested in, performance is so critical, right? So in the past, when one way is you have extreme control of your data structures. You can do a lot of optimizations, and so if you're working in C, in the old days we had you had hints you could give for where the compiler could potentially put something in the register or whatnot. But if we really look at the hardware, right, I think the new frontier is pretty obvious. It's memory. It's access to memory. It's the latency of memory. It's not so much as compute anymore, right? But then if you think about it, the hardware is going in one direction, which isn't really stressing it as much, right? So, the idea is the hardware will figure out, it'll put stuff in the cache for you so you don't have to think about it. So as compiler guys and VM guys, well, then you don't think about it either. So maybe I guess my question is let's say if you think of it not necessarily as a hardware person, not as a language or VM person, but as a problem solver. And you see, you really care a lot about performance, and you kind of say, okay, well, this is locality is the king. That's what we got to address, or one of the things we have to address, right? So if that's the case, what are the mechanisms that you envision that you could put in an adaptive optimizer, or potentially at the language level, or at the runtime or VM level, that could give you some support for these kinds, especially for data structures that are inherently so dynamic that you can't, you can't a priori, flatten them out. So how do we deal with this? Because this is at least in my world, this is a very practical, pragmatic problem.
All right, mechanical sympathy. Who here has mechanical sympathy? I don't think JavaScript has much mechanical sympathy, but who knows, Jonathan?
I know. Let me go for my previous life here.
Okay.
So, wow, the cheeky answer is Fortran's the answer. And go back to people that do supercomputing codes and ask them. They've been doing high performance parallelism on massive scales. But the problem is they don't really care about abstraction. Abstraction slows them down. They don't like it. A language like Chapel, which I worked on in the past, tries to have a level of abstraction and tries to maintain the performance that you get from some of the Fortran codes. Then the adoption's the problem, because they want to be able to stare at the Fortran code, and they're so trained over decades of working on these codes, they can look at it and tell you what that performance is going to be. It's going to be hard to beat that.
Quick.
Sure.
I believe I've seen papers at previous OOPSLA conferences dealing with adaptive optimization to improve cache locality. So I think there's work been done in that area.
All right, I'll give Andre the last word about, you can make a kind of commercial for D as the language for mechanical sympathy.
I've been on the HHVM team for 6 months, and I was very surprised by this, programs they know for 10, 20 years what's going on. I don't know what's going on from 1 month to the next. Things change so quickly. And doing that work, there's also others here. We've noticed that it's very difficult on today's complex machinery to predict what the performance impact of any specific code pattern or data layout is gonna have. So essentially, the focus of systems languages such as C++ is to essentially put that power in the hands of the user and let them lose. Let me give an example. GNU has 4 keywords dedicated to inlining. 4. They couldn't have 1. inline. There's inline, there's always inline, which doesn't always inline. There's never inline, which sometimes inlines. There's underscore inline, which is also for C, and probably there's a couple I forgot. And we use all 4 in HHVM because they do matter. And the way to discover which functions are good for inlining and which not to the candidates is very much a trial and error process. It's like making steel in the 1500s. It was incantations and Burke laws and that kind of stuff, right? So as a sort of user level and program level and implementation level advice, I have a very simple piece of advice to give. Use arrays.
Or and now, if you go there, I want to ask Alex, what about kind of Java unsafe? Isn't that what people use to kind of get high-performance Java?
Yes. And this goes back to what was the earlier question about removing features or assessing the value of features. Yes, there is a class, Sunmisk Unsafe, that allows you to do off-heat. Well, you can do off-heat memory access with it. Whether you are allowed to be using it for that is another matter. And given that that is one of the features that we think people abuse a lot, we've actually done some quite careful analysis of how people use that to go beyond the limits of the Java language, since it is sort of slated for removal any year now. And it's not that sort of normal programmers use it, but the libraries that almost all normal programmers use transitively will at some point use it. And so when you're thinking of removing something like that, so I'm actually answering the question from half an hour ago, the more data, the merrier. But it's not a language feature; it's an API feature because we never remove language features. So that's a moot question.
Okay, then I'll give the last word to Bjarne.
I was just saying that there's often a huge difference between what people think is efficient and what is efficient. Like I've seen some of those Fortran programs that was deemed very efficient because they used 10,000 processors. Yes, but they used 1% of the capacity of each of those processors, and that's not impressive. So I would like to emphasize that we need better measurement tools and better tools for representing the results of measurements. And once we have that, we can start thinking about which controls we actually want. People always think they know the answer, and that's not all that common.
All right. Okay. Well, you get the last question.
No, I just wanted to wrap up by thanking Mads for this amazing 2 days. So, thank you.
Yes, and thank you all the speakers for great talks and the great panel, and of course the audience. Where would we be without the audience, and why would we do it if it was not for the audience? So thank you very much, and I hope that Mads will organize another one. When it's like every 2 years or something.
Every year.
Every year.
If you can find the money.
Okay. Every year. All right. Okay. Thank you so much, and see you next time.